After being acquainted with trigonometry, we now move on to chapter 9, which discusses the applications of trigonometry. So here we'll be making use of those trigonometry ratios that we learned in the previous chapter. So here you remember the trigonometry ratios are all about the relationships between the different sides and angles in case of a right angle triangle. So there we discussed how many trigonometry ratios? We discussed 6 of them. I would be glad if you could name all of them. So they were sine, cos, tan, then we had cosec, sec and cot. Yes, we'll be making use of all of them in the applications now. So in the last chapter we boasted a lot about trigonometry, that it has got a plethora of applications. So we talked about astronomy as well, that we can use trigonometry to calculate distances between Earth and Sun or Earth and other stars. So we'll just see how we do that. In fact, there's a very interesting device called a theodolite. It's spelled like this. So it's actually an instrument which is based on the principles of trigonometry only, and with that you can measure angles by means of a rotating telescope. Apart from that, we can use it in geography, even your latitudes, longitudes, which help you to determine the position of an island with respect to them. So here we'll be focusing on the heights and distances of various objects. Okay, we won't be measuring them directly, but we'll see how indirectly we can get them by making use of trigonometry ratios. So I told you that our main focus would be on heights and distances. So this brings us to 3 important definitions, 2 of which you can see on your screen right now: line of sight and the angle of elevation. Okay, so say you are a person, okay, standing at point E, and let's say your height is AE. So AE is representing a person, and now you are standing at some distance from a tower. Let's say this is our tower CD. So what is the distance between the foot of the tower and you? That will be this distance ED. And if I join this A with line CD in a perpendicular fashion, let me call this point B. So you can see ABED, ABDE actually, that becomes a rectangle. So now here we have this line of sight. So what does this mean? So let's say this is your eye. So this is the eye of the observer. And this is the point which you want to see. Okay, this is the top of the tower. And this is your eye. Okay, this is your eye. And this point C is representing the top of the tower. So the distance between your eye and the object that you are viewing, in this case, which is the top of the tower, this distance is called the line of sight. So basically, this distance AC will be the line of sight. And what about the angle of elevation? Now we'll be discussing 2 angles in this chapter. Okay, so number 1, we have angle of elevation, which as the name suggests is some angle above your height. And number 2, we'll be discussing angle of depression, which again as the name suggests is an angle that you're visualizing below your height, okay, or below the eye level. So this angle of elevation, angle of depression, both these angles, they are measured from a horizontal level. Okay, never make this mistake of measuring them from a vertical angle or from a vertical level. They're always measured from a horizontal level. Okay, so in this case we can have this horizontal level AB, we can have this horizontal level ED. So which one do you pick? You pick the one which is forming an angle with the line of sight. So this is a line of sight AC. So this is the angle that you are referring to as your angle of elevation. Okay, so this is the angle between the line of sight and the horizontal. What is the horizontal in this case? Your eye level. Okay, this is your eye level, normal eye level, and this is the line of sight. The angle between them is angle of elevation. The only thing in elevation is that since it means at some height, so in this case you will be obviously having your head up, okay, to visualize an object which is above your eye level. So that is the only thing that will help you differentiate between angle of elevation and angle of depression. So in this chapter, basically there will be lots of examples, and you need to visualize the situation by means of some right angle triangles, like we have this over here. So this was your height AE, and this is your horizontal eye level, and the angle which it is making with the line of sight is the angle of elevation. Alright, so can you see right angle triangles in this case? So here we can see this triangle ABC. Now a very important thing, okay, if height of a person or any observer, if height of person is not mentioned in the question, okay, there is no mention of the height of the person, then you have to always assume the height of that person to be equal to 0. Okay, so if this height becomes 0, so basically you are diminishing to a point E, then actually the triangle which you will be considering will be ECD, where angle D is also 90 degree. Okay, now why am I taking AE to be negligible? Because if you compare yourself, okay, with the height of a tower, with the height of a building, you're obviously very small in front of it. So we can assume AE to be 0 in this case. Basically your height can be assumed to be 0. So this is basically an approximation that we can make use of to simplify our work, to simplify our calculations. Many a times we'll be making this approximation that we'll be considering the height of the observer to be 0. Until and unless it is specified in the question, you have to take it to be 0. Please make sure of that. I told you that after angle of elevation, I'll also be talking of angle of depression, and here we are. Now, as the name suggests, depression. Depression means down. Okay, so by depression over here, we mean that you are looking below the eye level. Okay, so if this is your eye level, you are looking below the eye level. So basically, you have to lower your head this time to visualize the object. So let's say instead of being on the ground this time, your object is on the ground and you are on top of this building. Alright, so this is you. And again, what will be the horizontal level here? Your eye level is only the horizontal level, your normal eye level. This is the horizontal level. Alright, now what is the importance of this horizontal level? Just think a bit about it. The importance is because be it angle of elevation or be it angle of depression, both are measured from the horizontal level only. And in fact, both of them are angles formed between the horizontal level and the line of sight. What is the line of sight in this case? So this is your eye and this is your object. So the distance between the two is your line of sight. So you take the angle between horizontal level and a line of sight, and that gives you your angle of depression. Is it clear? So again, we can visualize a triangle like this. Now obviously this building is standing vertically. A building cannot be tilted unless it is leaning Tower of Pisa. So here we are having this building standing erect on your ground. So this angle will always be 90 degree. And if it is a right angle triangle, it's very good for you because you can easily make use of your trigonometric concepts here. So this is your AB tower. You are standing over here. So this is the case where we are assuming your height to be 0. And this is your eye level, horizontal level, and this point A is actually your eye. And this is your object at point C. The distance between your eye and the object is line of sight. And the horizontal level, which is the normal eye level, is this AD. And the angle formed between this horizontal level and line of sight is what? The angle of depression. Okay, so what is the difference basically between angle of elevation and angle of depression, and what are the similarities? Let's see if you can answer these questions. So let's talk about the similarities first of all. So both of them are angles, obviously, first of all. But what are the angles between? They are angles between your line of sight and horizontal level. Now, the line of sight is the same basically. If you stand over here or if you stand over here and this is your object, the line of sight will be the same, but the horizontal level is where the difference creeps in. Okay, so here the horizontal level in case of angle of elevation is at a height lower than that of the object, but here it is above it. Okay, so basically here you have to in case of angle of elevation you have to put your head up. Okay, in angle of depression you have to lower your heads. So basically this is above your eye level and angle of depression is below the eye level. So this chapter is all about heights and distances. So these are the heights that we are considering, okay, like AB. Distances are like distances between the foot of this building and the object, okay, distances like these. So like here we can make use of trigonometry ratios. So if I give you one angle, okay, it could be angle of depression, angle of elevation, and I give you the height or say the distance, you'll automatically be able to make use of trigonometric ratios to find the other parameters of your triangles, which are nothing but visualizing your situations only in real life. So the main focus in this chapter would be to find the distance between two or more places, or to find the height of an object, or in very rare cases where you have to find out the angle which is being subtended. Okay, it could be of depression or it could be of elevation. So what are its applications in your day-to-day lives? So for example, there's a person who is building a roof. Okay, so the roof can be like this horizontal, but you also see these roofs like these, tilted. So then they are at some angle. Okay, so their trigonometry plays a very important role. Or for example, you are sitting in your room right now, okay, and you want to measure the angle at which sunlight is falling inside your room. You can make use of all these trigonometry ratios to make your life simple, to get answers to all these questions. So now moving on to examples. So there is a tower which stands vertically on the ground. So this is a tower, and from a point on the ground, this is 15 meters away from the foot of the tower. So if this is a point on the ground, then its distance from the foot of the tower is 15 meters. I urge you to make this figure with me step by step. Then from this point, the angle of elevation of the top of the tower is found to be 60 degrees. So for angle of elevation, you need two things. You need a horizontal level. But has there been any mention about the height of the observer? No. So in that case, we take the height of the observer to be what? 0. So that is an approximation. So height of observer is 0 in this case. So basically this is your eye level. So this is only your horizontal. This is your horizontal. Another thing which you need is a line of sight. What will be the line of sight? This eye and the top of this tower. That is what you're visualizing, right? So this is your line of sight. And the angle between this horizontal and line of sight. So this is your line of sight. This is your horizontal. The angle between them is 60 degrees. Okay, this is basically your angle of elevation. So for this situation, can you visualize a right angle triangle? So this is basically your figure. Okay, this figure boils down to a simple right angle triangle A, B and C. Now you tell me, where is the right angle at? Is A a right angle? We don't know. What about C? Definitely not, because it has been given that this is 60 degrees. What about this angle B? This is 90 degrees, because this tower is actually standing vertically on the ground. Okay, if it stands vertically on the ground, it means that this angle is 90 degrees. You have to find out the height of the tower, so you basically need to find out AB. You have been given this distance BC as 15 meters. So now this is a simple problem, okay, where we discussed this like an introduction to trigonometry. So here you tell me, we have one side, we have one angle. We need to find out the side AB. Which trigonometry ratio do we make use of? You discussed 6 of them in the previous chapter. So what we need to find out is the side opposite to this angle, and we have been given the adjacent side. So is there a relation between the opposite and adjacent sides? Yes, there are two trigonometry ratios. We have tan and we have cot. Let's make use of tan. So tan of 60 degree. I'm considering triangle ABC, okay? So tan of 60 degree will be what? The opposite side, which is AB, upon the adjacent side, which is BC. So tan 60 degree is what? Root 3. AB is what you need to find out. BC is actually known to us, that is 15 meters. So if you multiply them, you get AB as 15 root 3 meters. Okay, the unit has to be meters. So this is your answer. So the methodology in all these questions would be to make use of all the information that is given to you in the question, make triangles out of it, and then look for the sides and angles which are known to you. Make use of your knowledge of trigonometry ratios and solve the questions, compute whatever they are asking for. So here we have an electrician. He has to repair an electric fault on a pole of height 5 meters. So we have this pole over here, and what is its height? 5 meters. She needs to reach a point. That means we are talking about a girl who wants to reach a point. So let's say she's making use of a ladder. She's not a monkey, so she won't be able to climb it directly. So she makes use of a ladder. Okay, and she's not reaching the top of this pole. She wants to reach at a point 1.3 meters below the top of the pole, which is basically this point. That means this distance is 1.3 meters. Then you have to find out the length of the ladder, which means this distance you want to find out. And the inclination of this ladder is given 60 degree to the horizontal. Now here by horizontal we are referring to the ground level, okay, and this 60 degrees the angle. So the 60 degrees nothing but in a way angle of elevation only. So if this is the foot of your ladder, from here this point, okay, 1.3 meters below the top of this pole, this is your line of sight. Horizontal level is your ground level, so this angle is 60 degree. And can you visualize a right angle triangle over here? In addition to BC, you also need to find out this distance DC. Okay, basically how far from the foot of the pole she's going to place the foot of the ladder. So how do we do this? So basically we are considering this triangle BDC 90 degree, 60 degree. Now obviously we have say this point A. If this entire height of this pole is 5 meters, then so basically AD is what? AD is 5 meters. AB is given to us as 1.3 meters. So can you tell me what is BD? BD will be this entire height AD minus this small section AB. So it will be 5 minus 1.3 meters. So how much will it turn out to be? 3.7 meters. So your BD, this distance is 3.7 meters. So I know the side opposite to 60 degree and I want to find out the side which is the hypotenuse of this triangle. So what is the relation? What is the trigonometry ratio that we will be making use of which links the opposite and the hypotenuse of a right angle triangle? That is sine or cosec. So let's make use of sine. So sine 60 degree, okay, I'm considering triangle BDC. Sine 60 degree is side opposite BD upon the hypotenuse which is BC. Now what is sine 60 degree? That is root 3 by 2 and it is equal to BD which is 3.7 upon BC. So BC is equal to 3.7 into 2, okay, just cross multiplying in a way, upon root 3. Now they have given that root 3 can be taken to be as 1.73. So it means that BC is equal to 3.7 into 2 upon 1.73. So when you calculate this, your BC will approximately turn out to be equal to 4.28 meters. So we found the length of the ladder BC as 4.28 meters. Then you can make use of Pythagoras theorem to find out DC, or you can make use of your another trigonometry ratio to get the value of DC. So let's make use of a ratio which links the side opposite and the sides adjacent, okay, to with respect to this angle 60 degree. So let's consider tan 60 degree in this triangle AD, in this triangle BDC only. So it will be the side opposite which is BD upon the side adjacent which is DC. So tan 60 degree is root 3 which is equal to BD, that is 3.7 upon DC. So DC will become equal to 3.7 upon root 3. What can you take this root 3 as? 1.73. So 3.7 upon 1.73. So when you solve this, you will get DC as 2.14 meters approximately, okay. So the length of the ladder is 4.28 meters and the distance between the foot of this ladder, that is point C, and the foot of this pole D, that is DC, will be 2.14 meters. Moving on to the third example. So there is an observer 1.5 meters tall. So this is the observer, his height is 1.5 meters. He is 28.5 meters away from a chimney. So this is your chimney and the distance between chimney and this person is 28.5 meters. The angle of elevation of the top of the chimney, okay, this is the top of the chimney, from his eyes is 45 degree. So this is your eye level. So since here the height is specified, so you don't have to take this as eye level, but this as eye level and this will only be your horizontal as well. And what will be your line of sight? This will be your line of sight, the distance between his eyes and the top of this chimney. And the angle between the two is the angle of elevation, which is 45 degrees. So this is how it looks. So here also you can visualize the right angle triangles. So this is the top of the chimney A, this is your foot, this is your head, CD is the height, and B is the foot of this chimney. You have to find out the height of the chimney. So this height will be what? AB. So in the question, AB is what they are asking. So here, if you look carefully, DEBC, what is the shape of this DEBC? It is a rectangle. Okay, so what is so special about a rectangle? That opposite sides of a rectangle are equal. So if DC is 1.5, EB will be equal to 1.5 meters. Also, if CB is 28.5 meters, I can say that DE will also be 28.5 meters. Why? What is the reason? They are opposite sides of rectangle. They are opposite sides of rectangle. So that means this is 1.5 meters and this distance is what? 28.5 meters. So in order to find AB, you need to find out AE and EB. Okay, AB is equal to AE plus EB. Now we don't know AE, but we know EB, that is 1.5 meters. So basically, if you want to know the value of AB, you need to find out this distance, this height AE. Okay, so how will you find this AE height? You need to consider this triangle ADE. Triangle ADE. Now you tell me, is it a right angle triangle? Yes, it is, because this chimney is also standing vertically on the ground and this angle AED is 90 degrees. So here I have one angle and I have the side adjacent to this angle. I want to know the opposite side. How can you relate the opposite and adjacent sides of a right angle triangle? By means of tan or cot. So let me make use of tan. You can also try out with cot. So tan 45 degree will be equal to AE, the side opposite, upon the adjacent side, which is DE. Now what is tan 45 degree? That is 1. It is equal to AE upon DE is what? 28.5 meters. So if you bring this up, you get AE as 28.5 meters. Now once you have this value of AE, EB we already found out in the beginning, that is 1.5 meters. You can easily add them and you will get AB. So AB is equal to 28.5 plus 1.5, and you tell me then what will be the height of this chimney. So that will be 30 meters. So the height of this chimney is 30 meters. Then from a point P on the ground, the angle of elevation of the top of a building is 30 degree. So this is the point on the ground P, and then you have a 10-meter tall building. Okay, now since again there is no mention of any height, so we are assuming the height to be 0. So the horizontal will be this only, the distance between P and the foot of this building. And this is the line of sight. Okay, you are visualizing the top of this building. Okay, so that is this line of sight, and this is the horizontal level. The angle between them is 30 degrees. So basically it looks like this. Then they are saying a flag is hoisted at the top of the building. So this is your flag and the angle of elevation of the top of the flag staff. So now this is your object, this is your point P. Okay, the line between them is the line of sight. The horizontal will still remain the same, which is this, and the angle between this line of sight and this horizontal will now be 45 degrees. So let me take this point as B, that is the top of the building, and the top of the flagstaff is taken to be D. This is a point P on the ground. You have to find out the length of the flagstaff, which means you need to find out BD. And you need to find out the distance of this building from the point P. Let's say this is the foot of this building, so you need to find out the distance AP as well. So here you can take root 3 as 1.732. So let me make these triangles over here. So we are having two small right angle triangles. What is this point? This is point D, this is B, this is A, this is P. Okay, then what is this angle? This is 30 degree. And this huge angle is 45 degree. Alright. And what else have we been provided with? This height AB is given to us as 10 meter because this is the height of my building. So I can consider this triangle ABP. Is it a right angle triangle? Yes, this angle A is 90 degree because the building is standing vertically on the ground. So in this triangle ABP, I know the opposite side. Alright, I want to find out, say, AP in this case. Okay, to find out AP, I will need a ratio which links the opposite and adjacent side. So that is tan or cot. So let me make use of tan. So we will get tan 30 degree as AB upon AP. What is tan 30 degree? That is 1 by root 3. So that is equal to AB, which is 10 upon AP. So if you cross multiply, you will get AP as 10 root 3 meters. So we've already found out the distance of the building from the point P. Now since they've given root 3, you can make use of this value of root 3, 1.732. So 10 into 1.732 also you can do. And when you do that, you will get as 17.32 meters. This is your distance AP. Okay, what is this distance of the building from the point P? Then you need to find out the length of the Flagstaff. Okay, that is BD. So this we've calculated. Now this AP is 17.32 meters. Now you can focus on this big triangle, which is triangle ADP. So triangle ADP, it is also 90 degree angle. Angle A is 90 degree. And you have this angle 45 degree. So I want to know this distance AD, okay, because from there I can get BD, right? So to get the value of AD, I can make use of tan 45 degree, or I can even make use of cot 45 degree. So tan 45 will be the side opposite, which is AD upon the adjacent side AP. Tan 45 degree is what? Tan 45 degree is equal to 1. So this will become AD upon AP is 17.32. We've just calculated this. So AD will be equal to 17.32 meters. But are we done here? No, we needed to find BD. But AD itself is equal to what? AB, the height of the building, plus the height of the Flagstaff, which is BD. We know AD, that is 17.32. We know AB, it was given in the question as 10 plus BD. So on solving, we will get BD as 7.32 meters. This is the height of the, or the length of the Flagstaff. Then we have a tower standing on a level ground. This is a tower, and obviously when there will be sunlight, there will also be a shadow of every object. So we are visualizing its shadow at two angles, okay, once at 30 degree and the next time at 60 degree. So at 30 degree, this is the angle of elevation only in a way, from the tip of this shadow to the top of this building. And then you have the angle of elevation 60 degree. So now you tell me, this 60 degree will be ahead of 30 degree or will it be behind 30 degree? Where will it be? Your 60 degree angle would be somewhere over here. Okay, so just keep in mind, whenever you have been given multiple angles of elevation, so you will have this as the perpendicular. Then you look at the smaller angle. So the smallest angle comes at the farthest distance, and as you increase the angle, it will move closer to the foot of this perpendicular. Okay, if I keep on increasing the angle, it will keep on moving closer to your foot of perpendicular. Okay, so 30 degree will come here, 60 degree will come here, and these are basically your shadows only at two different angles. But what have we noticed, that the shadow with 30 degree is 40 meters longer than when it is 60 degree. Okay, this means that this shadow is 40 meters longer than this shadow. Okay, we have this shadow and we have this entire shadow. The difference between the two shadows is of 40 meters. Find the height of this tower. So basically this is your triangle. So this is the height of the tower AB. Okay, when the angle of elevation is 60 degree, and then we have this angle of elevation as 30 degrees. This is point D, this is point C. So BC is the shadow when angle of elevation is 60 degree, and CD is the shadow when the angle of elevation is 30 degrees. So this is 40 meters. So it has been given that when angle of elevation is 30 degree, the length of the shadow is 40 meters more than when it is 60 degrees. So this obviously means that DC is equal to what? It will be 40 meters plus BC. So let me say BC, the length of shadow when the angle of elevation is 60 degree is x meters. Why am I having the unit meters? Because here in the question also they are making use of this unit. So in that case, DC will be 40 plus BC, which is 40 plus x meters. Okay, so this is x and this entire BD will then become 40 plus x, right? So now consider triangle ABC, okay, this triangle. Now obviously this is a right angle triangle. Why? Because this tower is standing vertically on the ground. So in triangle ABC, I know this angle. Okay, what do I need to find out? I need to find out AB. I know this side BC, okay, basically I have assumed it to be x and I want to find out the side opposite. Opposite and adjacent sides are linked by tan or cot. So let me take tan 60 degree, side opposite, that is AB, upon the side which is adjacent, that is BC. So tan 60 degrees root 3, AB is what we need to find out, BC is x. So from here we get AB as x root 3, unit being meters. Then you consider triangle ABD. That is also a right angle triangle if you see. So here again my focus is on AB only, okay. So I'll find out tan 30 degree, that will be the side opposite AB upon the adjacent side which is DB. So tan 30 degrees 1 by root 3, it is equal to AB upon DB. Now DB is DC plus CB, so I can write this as x plus 40. If I take this over here, I will get AB as x plus 40 upon root 3. So here I am getting some value of AB from triangle ABD, and from triangle ABC this is the value of AB that I got. I can compare the two values. So I can say x root 3 is equal to x plus 40 upon root 3. Let me take this over here. X into root 3 is 3x. So 3x is equal to x plus 40. I take this x over here, it becomes minus. So 3x minus x is equal to 40. So this gives you 2x equal to 40. This gives you x equal to 20, unit being meters. But we did not require BC in the question. They were asking you to find out the height of the tower AB. So you can find AB from here. AB was x root 3. X is 20. 20 root 3 meters is the height of the tower. So this is your answer. Finally, we are done with angles of elevation. Now we'll be focusing on angles of depression as well. So you have been given an 8-meter tall building. This is your building. And then we have a multi-storied building. So this is them. So we are looking at the angles of depression of the top and the bottom. Angle of depression means you are standing over here somewhere. See, okay. So let's say you are standing on the top of this building. So you are visualizing the top of this 8-meter tall building, and then you are visualizing the bottom part of this building. So the two angles of depression in that case are 30 and 45 respectively. So this is for the top 30 degree. And this is for the bottom 45 degree. You have to find out the height of the multi-storied building, which is this height, and the distance between the two buildings, which is this. But for this you need to visualize the right angle triangles. Okay, so let me join these two lines first of all, and then this is what I am getting. This is like my figure over here. Now obviously this building is standing vertically on the ground. So this angle is 90 degree. Also this angle is 90 degree because BD is perpendicular to PC. So what do you need to find out? The height of the building, which means PC is question mark, and you need to find out the distance between the two buildings, which means AC is also question mark. We need to find both of them. Now here, if you carefully notice, this PQ is actually parallel to BD. PQ is parallel to BD. So I can say this angle QPB is equal to angle PBD. What is this angle QPB? 30 degree. So if the two lines are parallel, I can basically say that alternate angles are equal, and hence this angle also becomes equal to 30 degree. Okay, so I am considering this triangle PBD now, and in this triangle PBD, I know one angle, that is 30 degree. Okay, now consider this BDCA. What is BDCA? It is a rectangle. So if AB is 8 meters, your DC should also be 8 meters. So we know this DC is 8 meters, and what is this? This is your opposite sides of a rectangle. So now what you can do over here is that consider triangle PAC now. Okay, now here as well, if you notice, AC is parallel to PQ, and if I have been given two parallel lines, then angle QPA will be equal to angle PAC. okay, which is equal to 45 degree. Why? Because they will be alternate angles. So far I'm just trying to make sense of my figure, okay, by basic geometry knowledge actually, and now I'll make use of it. Okay, so I don't know this distance, this height, PD. If I know this, then I can add PD and DC. I'll be easily able to get PC. So what you can do over here is, in this triangle PAC only, you find out tan 45 degree. That will be equal to what? PC upon AC. Now tan 45 degree is 1. So 1 is equal to PC upon AC. So this means PC is equal to AC. Further, we just discussed PC is what? PD plus DC. So this is equal to AC. And what is DC? DC is 8 meters. We got it from opposite sides of rectangle. So PD plus 8 is equal to AC. Then further, if you notice, AC and BD are equal. Okay. AC and BD are equal. Again, give the same reason, opposite sides of rectangle. Which is the rectangle over here? BDCA. Alright. So that means your AC is same as BD. So I can say PD plus 8 is equal to BD. Then what you can do here is you can make this equation number 1. Alright. Then move back to this triangle PBD. So triangle PBD. Now here again find out tan 30 degree, because basically I want to know the length of the opposite side. Okay, in order to get the height of this building. So that will be PD opposite side upon BC the adjacent side. So what is tan 30 degree? Okay, this is BD. So tan 30 degree is 1 by root 3. It is equal to PD upon BD. So from here, if you cross multiply, you get BD as PD root 3. So if you make this equation number 2, now consider these two equations and equate them. BD is common in them. So we will equate them. So your first equation was what? BD is equal to PD plus 8. And your second equation was BD is equal to PD root 3. So equate 1 and 2. You will get PD plus 8 is equal to PD root 3. Let me bring this PD on the RHS. So we get PD root 3 minus PD is equal to 8. You can take this PD common. So you will get PD into root 3 minus 1 is equal to 8. Make this PD subjective formula. So you will basically get PD as 8 upon root 3 minus 1 meters. Okay. So I knew DC already, 8 meters. So can I find out PC now? PC was what? PD plus DC. So it will be 8 upon root 3 minus 1 plus 8. But you need to rationalize this factor. Okay. You can't have irrational number in denominator. So at this stage only you can multiply your numerator and denominator by root 3 plus 1, its conjugate. So 8 into root 3 plus 1 upon root 3 minus 1 into root 3 plus 1. Now a minus b into a plus b is what? A square minus b square. So this will become root 3 square minus 1 square, 3 minus 1, 2. So 8 into root 3 plus 1 upon 2. So this becomes 4. So PD basically becomes equal to 4 into root 3 plus 1 meters. So here you can write this term as 4 into root 3 plus 1. So PC becomes equal to 4 into root 3 plus 1 plus 8. If you open the brackets, you get 4 root 3 plus 4 plus 8, which is 4 root 3 plus 12. Now here you can take a 4 common. So you will get PC is equal to 4 into root 3 plus 3 meters. So this is the height of the building. Then you need to find out the distance between the two buildings. So the distance between the two buildings is AC, and AC is equal to BD. So let me find out BD only. So BD is equal to PD root 3. You can make use of equation number 2. PD is 4 into root 3 plus 1. So here you will have 4 root 3 into root 3 plus 1. If you multiply this, you will get BD as 4 root 3 into root 3. That is 4 into 3, 12. Plus 4 root 3, take a 4 common, you will get 3 plus root 3 meters. So BD is same as AC only. So the distance between the two buildings and the height of the multi-story building are turning out to be equal, 4 into root 3 plus 3 meters. So then we have example 7, the last example in this chapter. So from a point on the bridge across a river. So we are having this bridge across a river, and we take a point on this bridge. Let's say the point is point P. Okay. The angle of depression of the banks on opposite sides of the river. So we are having these banks, okay, this is one bank, this is another bank on the opposite sides of the river, and we're looking at the angles of depression. So here the angle of depression is 30 degree and here we have it as 45 degree. And the height of the bridge is 3 meters from the bank. So the height is 3 meters. Can you visualize any triangles over here? So these are the triangles. You have to find out the width of the river. The width will be the distance between the opposite banks. So basically you need to find out AB in this question. Now this is my horizontal. Okay, let me call this point Q, let me call this point R. So we know that PQ is parallel to AD, obviously. So we can say that angle QPA is equal to angle PAD is equal to 30 degree, okay. So you make use of alternate angles, okay. And similarly we see that PR is parallel to DB. So this angle RPB is equal to angle PBD is equal to 45 degree. Again the reason would be what? Alternate angles. So basically I am having a triangle. Okay, this is P, here we are having, obviously this is perpendicular, okay, you always measure the height in a perpendicular fashion. So this is AB, the two banks, and here we are seeing this angle is 30 degree, this angle is 45 degrees, this is 3 meters, and this is D. So in order to find AB, AB is what? AD plus DB. So if you get these two lengths, you will be able to find AB by adding them up. So consider triangle APD. You need to find a ratio which gives you the adjacent side if the opposite side is given to you. So you make use of tan 30 degree in such a case. The opposite side PD upon the adjacent side AD. What is tan 30 degree? That is 1 by root 3. PD is 3 upon AD. So AD on cross multiplication will become 3 root 3 meters. So this is 3 root 3 meters. Then you need to find out DB, for which you consider which triangle? PDB. So triangle PDB. Here again we'll make use of tan 45 degree. You can also make use of cot, okay. What is the opposite side here? PD. What is the adjacent side here? DB. What is tan 45 equal to? That is equal to 1. So 1 is equal to PD, that is 3 upon DB. So on cross multiplication you get DB as 3 meters. So if I know AD, if I know DB, can I add them up and get AB? So we can obviously do that. So basically your AB becomes equal to 3 root 3 plus 3 meters. If you take this 3 common, you get root 3 plus 1 meter. So 3 root 3 plus 1 meter is the distance between the opposite banks of this river, or in other words, this is the width of the river. So now time for a quick revision. Let's see how much you've learned from this chapter. So here, what property of trigonometry did we make use of to solve the questions? The trigonometry ratios. Okay, now what do we mean by the line of sight? What is it? It is the distance between 2 points. What are the 2 points? Between the eye of the observer and the object that you are viewing. Then from line of sight, we also made an important remark of on horizontal level. So what is the importance? The angle between the line of sight and horizontal level will only give you the two angles. It could be angle of elevation. If you're having your heads up, you're visualizing something above the eye level, and you can also have an angle of depression if you are having your heads lowered and you're visualizing something below the eye level. Okay, so here I have a quick exercise for you, and you'll identify which is the angle of elevation, which is the angle of depression in that figure. So let me give you a building A, B, and let's say you are standing on the ground. If I'm not talking about your height, that means I am taking your height to be 0. Okay, so you are over here at this point C and you're visualizing this point A. So tell me, what is the line of sight? So AC is the line of sight. What is the horizontal in this case? Your eye level. What will that be? BC. Then you tell me, what will be the angle of elevation in this case? If this is the line of sight and this is your horizontal, tell me what will be the angle of elevation. And number 2, if say you are standing at this point A and you are visualizing some point C on the ground, then let's say this is your horizontal, okay, in that case. And then tell me, this will only be a line of sight, right? Tell me what will be the angle of depression. I'll give you some angles, you tell me. So let me give this as 30 degree, this as 45 degree, 60 degree. Now first of all, tell me what will be this angle ABC. This will be 90 degree. Why? Because this is a building, it is standing vertically on the ground. Now identify the angle of elevation over here. Is it 30 degree? Is it 45, 90, 60? What is it? It is 60 degree. This is the angle of elevation. Okay, it's between your horizontal and line of sight where the object is above the eye level. Then is 30 degree your angle of depression? No, it is 45 degree. 45 degree is the angle of depression in this figure. It is the angle between the horizontal and line of sight when you're having your heads lower to visualize an object C on the ground level. And what is 30 degree? It is neither angle of depression nor angle of elevation because this angle is being measured from the vertical sides, okay? But angle of elevation, depression, both of these angles are based on the horizontal level. Do you see any horizontal level measurement for 30 degree angle? No. So this is neither angle of elevation nor angle of depression. So that's it for this chapter. Thank you.